Hey, thanks for allowing me to talk about what DENSO's been doing in blockchain. I've I've been with DENSO's R&D department for 22 years almost now. Um, and before that, did a lot of work with consumer electronics and even Department of Defense contracting. So I have a long career history in connectivity and connected services and that kind of thing, and even a little bit of automotive and mobility now with Denso. So today I'm here to talk a little bit about uh, why Denso is involved in blockchain for one thing, and for the other, how to connect kind of this what we might call a cyber world of traceability to the physical world of product and how it's delivered and how it moves through the supply chain. So let me get started. I just want to introduce for the first part of the talk today how Denso's traceability system is come into fruition. So why does Denso think blockchain is important, and why are we involved in Mobi and in blockchain on a global basis? Really, it comes down to what the expectations from society are. Really, when we talk about uh, supply chain and traceability, we really want to fulfill the customer's need to really understand where things are coming from and how they got where they are and how they can be delivered to them. Definitely within the uh, confines of the pandemic, we've seen how important supply chain is to actually getting goods to our to our homes or to our enable us to use them, and how all along the supply chain, from the creation of raw materials to the delivery to consumers, is really important to understand where things get caught up and trace how they move through that supply chain. So that's become really more important for a lot of society lately. Notwithstanding, what we see now is a lot of governments setting up regulatory environments for how environmentally hazardous substances are handled, and in a large part due to some of the work from the European Commission, which I'll talk about a little bit later. There's really a momentum in place to kind of establish traceability for some of those hazardous substances, and in fact, the some of the raw materials used to make batteries, rechargeable batteries, which are coming into a lot more prevalent use, and especially in the area of mobility, are quite an important part of uh, of how electric vehicles and environmentally sustainable society will continue to grow. And last but not least, really, there's a kind of a desire from the community, from the public, to really understand where their products come from, how they're uh, sourced, how are they used, and how do they get from raw materials to, whether it's food on your table or a television set on your wall or a car in your garage. Um, how they get how they where they come from and how they get where to you, and the quality and sustainability of those supply chains. So part of what we're looking at in terms of the social impact of a traceability platform is really looking at some of these society matters, society issues, and some of the trends and expectations from society in the way that their products are sourced. And so we look to things like um, responsible sourcing for materials that go into products, like uh, uh, raw materials like rare metals that used in batteries or in other components. We talk about food sources, where they come from. Are they fit for consumption, and how did they get to the marketplace from the sources where they were grown? We talk about even during the pandemic, we had a delivery of COVID vaccinations that needed refrigeration, and so we need to regulate the temperature of, of the goods that are being delivered during the logistics, during the supply chain trail from source to destination. And I mentioned earlier there's some regulatory backing from governments around the world about how to manufacture, how to reuse, how to recycle important elements of transportation and mobility, including electric vehicle batteries, and how their usage over their total life cycle depends on how they're used. So traceability in that domain is also very important. We look at DENSO's traceability system, given that background on why we do traceability. We think there's some value added in from the end user in that they can purchase goods with reliable supply chains, and really the peace of mind that they know where their products come from and how they got where they are today. And from the company perspective, we can increase the perceived value of such products, being as though we can uh, trace their supply from raw goods all the way to finished goods, whether, as I mentioned, whether it's on your table at dinner or whether it's in your garage or whether it's something else in your house or some other product you use. Responsible sourcing goes a long way in showing peace of mind for a certain demographic of customers. So we see some in the idea from the traceability system, we see some pain points in how to establish and how to execute such a traceability system. For example, how do you avoid, if you have a traceability system, how do you avoid tampering with forgery of that traceability information? How do you really match the real product to the traceability information you have in your ledger or in your record keeping system? And do you really, in establishing a level of reliable traceability, do you increase the cost of such a system? And we think with our blockchain platform, we have a solution for those pain points. We can avoid tampering with the reliability, the authenticity of the information in our traceability system by using blockchain. Everyone who's on this call understands the utility of blockchain and how it can be used for immutable records of, of traceability, track and trace of a product from raw goods to finished product. The second one is, how do you match this kind of real product in the physical world to the traceability information that you can hold in your traceability system? And with that, we propose to use QR code, as Rajat mentioned in the introduction, QR code and barcode to establish an identity in essence for everything from raw materials to finished product. So we can provide that traceability and that chain of custody from raw goods all the way to finished product. And we use this barcode, which has been extensively proliferated throughout the world in very many different industries, all the way from your grocery store to product being created and shipped for the assembly of transportation vehicles, for example. And so the proliferation of that QR code allows us to do some special things to QR codes that allow us access to the traceability information without disrupting the original legacy record keeping systems in and along that supply chain. So we have a few different ways we can use QR codes. If you look at the matrix on the right, we have not just a simple normal, so-called normal QR code, which is widespread and used throughout the world. We have other adaptations of that where we can add to the existing infrastructure, but still do certain things that are valuable for certain industries and certain manufacturers or certain traceability systems that allow us to continue to use this, I don't know, almost 30-year-old technology in a way that allows us to incorporate traceability into the record-keeping systems for supply chains throughout many different industries. So we have been working on this blockchain system and this traceability system, I would say, that utilizes blockchain since around 2017, late 2016 to 2017. And we've prototyped a number of systems and showed their concepts and proof of concepts and proof of values to many different industries in the world, and are now promoting this kind of activity on a global basis for DENSO. The traceability systems we've worked on for the last 4 or 5 years really encompass a number of different industries and a number of different vertical markets, including traceability for food chain, traceability for mobility products, traceability for and institutionalizing the sort of circular economy with these traceability systems. So we've done a bunch of proof of concepts and are now trying to commercialize some of this work that we have done in the background and with the Mobi community to instill the idea that traceability and traceability systems are doable, they're feasible, they make sense, and I think they solve some of the problems that the expectation from society is looking at. So, I mean, why is DENSO's blockchain system different than anyone else's? We really took the idea of not just using blockchain, not just using QR code that we developed some 30 years ago, but really combining a bunch of different concepts to realize a traceability platform that doesn't really depend on the format of the data that's used in a traceability or a supply chain system, and doesn't really depend on the amount of data using certain techniques. So we've gone all the way from a unique ID for traceability using the QR code, which we developed, and different types of QR code that fit the needs of customers from a number of different vertical markets and a number of different situations and systems where they've already used QR codes or are contemplating using QR codes for traceability through the supply chain. We combine that with some of the aspects from blockchain about using hashing to keep trade secrets private during using this traceability platform throughout the supply chain, and using blockchain for the immutability of that record and going from raw materials to finished product, and avoid forgery or tampering with that traceability data as it flows through the supply chain with several companies that may not even necessarily do work directly with each other, but all constitute a lengthy supply chain of many companies perhaps in different industries that at least touch the product as it goes from raw materials to finished goods. So in the next slide, I have a short movie clip that kind of illustrates DENSO's traceability system, the background behind it, and how we think it's valuable for society and for this industry. Indulge me for a couple of minutes and look to learn about DENSO's blockchain platform. Oops.
Some of the real problems that can affect our society today are counterfeit food labeling and the exploitation of child labor in mining rare materials. Mandatory tracing of carbon footprint and recycled materials are proposed to achieve carbon neutrality. In order to solve these social issues surrounding producers and consumers, transparency in the life cycle process of moving goods through the supply chain is required. To solve this problem, DENSO has developed a traceability system that combines its proprietary technology of QR codes and a blockchain platform. DENSO's traceability system uses 4 technologies to achieve traceability that are independent of data format and data capacity. The first one is what we call unique ID. In order to match the traceability information with the object, we assign an ID that can be traced from raw material to each component part to a complete finished product. The second is a QR code. The world standard 2-dimensional QR code, developed by DENSO, is ideal for the management of individual part identity. Various QR codes can be selected depending on the application. The third is a hashing application. All data provided by each manufacturing process is converted into an encrypted hash value. It is not possible to recover the original data from the hash value, and hashing makes it possible to protect the confidentiality of the data and prevent tampering. We also reduce the data size by managing hash values with a fixed length. The fourth is a blockchain platform. The hash value from each process is incorporated in the traceability system. In the blockchain, hash values are registered in the distributed ledger. So even if tampering occurs, even in just one part of the supply chain, inconsistencies with other ledgers occur, and the disturbance can be detected instantly. QR codes are now used all over the world in many different industries and applications. DENSO's traceability system ensures consistency between products and their traceability records by simply attaching or embedding a QR code, and this in turn provides a visualization of the supply chain and distribution processes. QR in QR code, a new technology that embeds 2 types of QR code information in one QR code, can be introduced at a low cost while maintaining the existing infrastructure of legacy tracking systems. This unique QR code also plays a key role in protecting data from tampering or confidentiality, which can be a problem for some traceability systems. Therefore, together with the blockchain, the QR code protects customers' important information and prevents tampering. In addition, by using special QR codes developed independently by DENSO, such as transparent QR codes that do not interfere with the product aesthetics, the system has flexibility to match a wide range of businesses and can only be provided by DENSO, the originator of QR codes. DENSO's traceability system provides visibility into the supply chain and distribution processes and enables immutable transparency through all of the life cycle, from producer through consumer. This gives end users peace of mind and can increase the value of the goods sold using this method. DENSO has been working to realize a society in which people and goods can move safely. We will continue to contribute to the safe transfer of information as well as people and goods.
Okay, thanks for watching. That kind of talks about a lot of the concepts that I introduced, but want to give you an idea that it's not just a PowerPoint and movie clips that DENSO has been doing with blockchain, that we've really prototyped systems and are using them in certain proof of concept projects and programs that allow us to establish how such kinds of traceability systems will be used in Web3 type of a society. So I'd like to take the next few minutes and talk to you a little bit about our battery and carbon footprint traceability system and show you how we've leveraged our knowledge and development in QR code and blockchain to really start to establish a platform for how traceability can be used in the future society. So many of you who are on this call understand or have heard about the European Commission's future battery regulation. Here I give just a kind of a summary of how that has been introduced to the public. Whereas even in as far back as 2006, Europe and in other regions, I mean, this is probably in the news more than other regions, but Europe has started to look at battery recycling, rechargeable battery recycling many years ago, and it evolved into what Europe calls the Green Deal, and eventually into battery regulation. And what this really means is that the idea behind designing, manufacturing, selling, using, processing, recycling, destroying, and reclaiming batteries in the European community really becomes part of a regulatory environment, and that the states in the European Commission or European Union can really take this seriously, and they can even prohibit selling products that don't comply with some of these requirements. If you haven't investigated this or read about this, Rajat has, through Mobi's battery initiative, done a deep dive into this, and is really looking for how Mobi can incorporate and understand how this regulation affects their membership, and how we can prepare as a community to be able to comply with a lot of these regulations, specifically in this case targeting items that use these rechargeable batteries. And as we can see in the news lately, or the society is really moving towards sustainable mobility and sustainable transportation, and a lot of that comes from replacing internal combustion engines with electric vehicles or partially electric vehicles or hybrid vehicles. And so the sustainability of the entire battery supply chain is important to society, because mobility is such an important aspect of how we transport people and goods. And so this regulation is going to be quite important for society in the coming years. And we believe that Europe may have started this sooner than some of the other regions in the world, but I think that most of the rest of the world will follow on to this or something very similar in terms of regulating this industry from a traceability standpoint, from raw materials through first use, through recycling or destruction, or second use, or gathering some of the raw materials from electric vehicle or other industrial high capacity batteries to use in other domains. So here we have a little bit of a summary of that regulation, and a lot of the information that's required from a traceability system, not only raw materials from the raw material from the earth to the finished product, but also in terms of recycling or reuse of these EV or industrial batteries, and how we can trace their usage, which has an impact on how valuable and how they can be used in a second life, or how the materials can be reconstructed or recycled to new batteries, from raw materials essentially to finished product. So there's a lot of record keeping that's necessary, and we believe the traceability system that can incorporate the four aspects that I mentioned about identification, the treatment of data during the entire life cycle, all the way to recycling and reuse is important for future society. So DENSO has created an application that we believe allows us to incorporate some of these battery traceability requirements from the European regulation, and we feel other regional regulations that, if haven't come out already, are about to become requirements for supplying some of these components. And so we put together an application that you can use on a PC or on a smartphone that allows you to do battery traceability through a blockchain platform. This just illustrates some screenshots about how we can collect information, and I mentioned the QR code can be used to attach, in essence, attach the traceability information in the blockchain platform, or in the traceability platform, with the individual physical item, whether it's raw materials or halfway, component finished goods, all the way to final product, and that we can incorporate files and systems to record the data required by the European Commission regulation or similar types of regulation or legislation that's a requirement to be able to provide these products like electric vehicle batteries. And then we can put a system together that collects the right information that's immutable and traceable, and can be audited to comply with the European Commission regulations. In essence, this kind of traceability product, in particular, how it applies to electric vehicle batteries and mobility, is illustrated here about how we can use this application to scan an individual product, establish its traceability information associated with that physical item. You can look at the traceability, track and trace sometimes from raw components, raw elements, all the way to finished product, and even can trace in a kind of trusted trip domain this logistics information about where the product was created, how it got to where it is now, um, how it was treated when it went through there, and what kind of carbon footprint it may have generated, either in its construction or in the logistics along its supply chain. So I have another example here of a demonstration, since it can't be face to face, and I can't necessarily show you how DENSO has taken our ideas and our concept, but really built proof of concept or proof of value implementations of this traceability system that actually have been tested in the wild, in the real world. So let me run for you just another one short video clip to illustrate how our implementations can be used in terms of a battery and carbon footprint traceability.
This short movie will demonstrate our carbon footprint and battery traceability systems that were created by combining blockchain and the QR code. Here is a picture of the demonstration setup. On your left side, we show the battery and carbon footprint implementations, and on the right side, 6 different examples of special QR codes, particularly formulated for connecting your physical world to the cyber world of DENSO's traceability system. We will show you several demonstrations. Here we show the example demonstration for EV battery traceability. First, you see the launch page. Then you can scan the QR code on the battery module. After scanning, the application retrieves the traceability information in DENSO's blockchain platform. You can then view it in your local device, including the device's carbon footprint. By swiping left, you can see the upstream supply chain. By pushing the top right icon, logistics information is obtained. By pushing the bottom right icon, you can see the state of health for your battery. Using DENSO's traceability application, you can check the EV battery history, its carbon footprint, and its state of health from your smartphone. The physical and cyber worlds are now united. Here, we will introduce several QR codes for managing an individual battery. If we add the traceability data to your existing QR code or barcode, you have to modify your hardware. To avoid this modification, we developed several QR codes to hide the traceability data. We will show the demonstration of QR in QR here. A normal scanner or a smartphone that reads QR codes is usually only interpreting 2 colors. The darker color is recognized as black, and the lighter color is recognized as white. Therefore, a normal QR code scanner will only recognize the 2-color surface QR code. But, if we use our custom DENSO smartphone application, we can separate 4 colors, and then recognize both surface and hidden QR codes. By using the hidden QR code, we can easily connect to our traceability system, but your existing QR code or barcode scanner still operates, just as it did previously, with a simple QR code scan. This last demonstration shows a great example use case for a transparent QR code. If you want to avoid the impact by showing a QR code on the brand image of your product labeling, we can show you how a transparent QR code can do this effectively. In this case, the QR code is printed using a special ink. Under natural light, you cannot see the QR code. But, when illuminated by infrared light, you can see the hidden QR code and scan it effectively. By using this type of QR code, we can sustain the brand label imaging, but still connect your piece part to our traceability system.
So hopefully that illustrated the way we can use QR code to identify items, and several different ways we can incorporate QR code into the physical implementation of a piece part, so that our traceability system can link with the physical item that you're tracing. So in summary, from today's presentation, I showed that DENSO is prototyped these traceability systems using QR code and blockchain technology, and that this immutable record of raw goods to finished product can be maintained while keeping with incorporating privacy in terms of the intellectual property that might be associated with that going along those supply chains, and how that product performs or has been tested, or what it's made of and how it's made. And that we've used various types of QR codes, including QR inside QR, to maintain the record tracking or record keeping platform that's currently being used, but allow it to overlay, a blockchain traceability system, and without having the customer to, totally replace their current record keeping system. Or we can use a QR code that's invisible to regular normal light, and you won't even know that there's a QR code incorporated in your product. So that can keep that immutable connection between the physical piece part and the traceability record. And that we've done those demonstrations, and now we look to proliferate systems like this throughout the world, and incorporate and work with the Mobi community to kind of test and evaluate these systems to be used in real life, and incorporated in different supply chain traceability products and use cases, and really see how this kind of Web 3.0 world will incorporate the use of immutable records of blockchain and traceability, and maybe we can use this kind of QR code connection between the physical part and this blockchain-based traceability record to really establish systems that can comply with some of the regulatory requirements coming from society and expected from society as we move forward. So thanks very much for the time allowed to talk with you today. I appreciate you attending the presentation, and hope that I can answer some of your questions.
Thank you, Roger. Any questions for Roger? Well, while people are thinking about the questions, let me ask a few questions, Roger, if that's okay with you.
Mm-hmm. Yeah, sure.
So I was going through the slide that you presented about the 4 components,
Mm-hmm.
the user ID, the QR code, the hash value, and blockchain. So I'm interested to know, how are those 4 components connected, especially the QR code with user ID and hash value. So typically QR code resolves into something, right? It stores some attributes.
Mm-hmm.
So does that also store your unique ID, and you're processing the attributes in the QR code and hashing that?
Yeah, exactly. So during any step along the way of let's call it a supply chain, all the way from, we can put QR codes in raw materials. I mean, I remember reading a few months ago that NIST, it was looking at incorporating a way to inject components inside in a 3-dimensional barcode inside a silicon wafer, so that they can identify even and prevent forgery or black market of a silicon, system on a chip devices. And you could read this barcode with this 3D barcode with a scanner, depending on the incorporating these different levels of doping or impurities in the silicon wafer. You can do the same thing as I showed with your with an invisible QR code, in that you might not even know that there's a barcode incorporated that allows for traceability, or this kind of connection between this physical piece and this traceability platform record that you have, all the way from raw materials all the way to finished goods. And during any process in that whole supply chain, whether it's a process in the manufacturing plant, you can attach, for example, test records of a component or a piece part of a component to establish a quality level, and that QR code will be associated with that, that test record. And if somebody tries to attach, the test record to another part that doesn't hold that same QR code, there you can identify that test data isn't associated with that particular part, but with a different part with a different QR code. And so that I would call it that connection between this physical part, using whatever kind of QR code you want to use, and this traceability platform record of, let's say, performance or compliance with some standard or some performance indicator or some excuse me, some requirement for a piece part during manufacturing can be sustained from when that item starts with its raw material till it's a finished product ready for shipment to the next person along in that supply chain. So we think that by combining these four concepts of this kind of unique ID that resides in the QR code and this platform of kind of life cycle management from our raw materials to finished goods, and an immutable record of that, can establish at least some level of quality, and it can show the sustainability of the process, and it can get you immutable records of how these parts were made all the way from their raw materials to finished product.
We have two questions, Roger. One from Ben Town. He asked, I'm curious about the pros and cons of QR codes versus data matrix codes. Do you want to comment on that?
I don't know what data matrix codes are.
Okay. And then we have a question from Chris. You are a co-chair of the ITN initiative. Any plans to use the ITN for these applications?
Oh, absolutely. Yeah, the integrated trust network is exactly the kind of platform and kind of community where these kinds of applications about traceability and supply chain, supply chain monitoring are in the combination of using something like a QR code to attach the physical world with the cyber world, and the traceability platform is exactly the kind of thing that we're looking for, and one of the reasons why we have contributed to Moby's journey, because we see that systems like this are really solving some pretty complex society issues, whether it has to do with as I mentioned, as I talked about with the, responsible sourcing through, traceability of the supply chain in order to get goods from, onto your table or into your house, or how we can, responsibly recycle some of these rare earth elements that are used in transportation or mobility, and really have a sustainable society as we move forward. I think Moby is absolutely one of the preeminent, if not the preeminent, community in the world to be able to show how some of these things work and how valuable they are to a society of the future.
Thank you. Any further questions? So Roger, the QR code sticker, how do you prevent, because I've been asked this question before, because we were putting QR codes in the pallets for logistics, and somebody asked, what if somebody just takes that sticker out and puts another sticker with fake information? Like how do you prevent that?
There are obviously ways in which you can physically show manipulation or counterfeiting. We have certain QR codes. I didn't go into too much detail about the QR code itself, but we have ways of preventing forgery or duplication, where we can tell that a barcode label is not, I don't know, compliant, or is not the right one, I guess, if you will. It's not authentic. There's ways of doing that through the physical implementation of barcode. We could even, as I tried to show in one of the film clips, we can even put barcodes on systems that you won't even know there's a barcode there. So we can kind of prevent the kind of counterfeiting and forgery through methodologies like that. But there are techniques where we can determine that a barcode label is not authentic and is not the original one by using this, excuse me, this traceability system and this link between a physical barcode read and the traceability platform. But that's a good question. I get asked that all the time as well.
Yeah, we have another question from Ben. How do you prevent duplication without preventing reading? That's your answer. I think may touch that question a little bit, right?
Yeah. So there's, excuse me, there are techniques that we've used with barcodes in the past that that prevent duplication. And we have special barcode readers to enable that. That's one of the things that we think that is unique about DENSO and how we can treat barcodes is we have techniques for demonstrating that the barcode label is authentic, is an authentic one and not duplicated.
Any other questions? So Roger, what are your plans for all the POCs that you mentioned?
So yeah, so Moby is establishing this ITN, Integrated Trust Network, and we think that is a perfect way to deploy, experimental versions of these kinds of platforms and explore how the community might utilize these kinds of things. Traceability is only one of the, I would call it, big categories that we have in how we can use blockchain for mobility. there are other ways. I think I talked about this a couple of months ago in another of our Moby lecture series, that we can utilize we call like a side chain to explore the immutability or the authentication of data that is gathered from, let's call it like a telematic system, and how the vehicle behaves, what under what conditions it was used and how it was used, and a lot of the electronic systems data can be collected and be authenticated through the use of onboard blockchain in a vehicle that connects with a consortium level blockchain that might be part of a manufacturer's back-end telematics system. So traceability is one aspect. The other thing is about tamper-proofing data collected in the mobility systems, whether it's for exchange of value from money or paying for services, to just the authentication of data that's collected from in a kind of a mobility IoT system. And so we believe that there are many aspects of how to use blockchain and blockchain systems that can be used in the mobility domain. Traceability is one of them. Data collection, mobility, IoT kind of authentication of that data is another. And there's probably a bunch of different ways we can use that we can use systems like this in data tampering, preventativeness, that's a word, in applications and use cases that we haven't even thought of yet. So one of the very helpful aspects of being involved in Moby and in the working groups is to think about things like that, about use cases for this kinds of technology and how the data collected can be used to build better products, or to authenticate those products for consumers, or to authenticate the data that we collect and how we use that data to provide services for users of mobility. And so we think that we've almost just barely scratched the surface. Today I illustrated about how we use blockchain and QR code for traceability, but we believe there's many other capabilities that can be utilized in use cases that we haven't even thought about yet.
Yeah. We're almost top of the hour. So I thank you, Roger, for the presentation. Thank you all for joining. The recording of the video will be in our website in a week or so, Grace?
It should be up tomorrow.
Oh, all right, awesome. Well, thank you all for joining, and see you next time in the community lecture. Thank you, Roger, again.
Thank you.